Hi everyone, this is Mrs. GA, and today we're going to be solving radical equations. I have a quick warm-up for you guys before we get started, so please pause the video and hit play when you're ready to check your answers. Alright, so go ahead and check your work here. For the first one, if you rewrite both of these to have rational exponents, you can actually end up multiplying these terms together, whereas if you leave it as a radical, you can't because the index is not the same. So here's the expanded version, and I would rewrite 9 as 3 to the power of 2/3, so you can multiply it to 3 to the power of 1/4. And then for each similar base, you just add up the exponents, giving you with this. Now to write your answer as a radical, you can keep x separate, and then you have the 12th root of 3y to the power of 11. Or if you want to make it a single radical, we could just multiply this by 2/2. So it's 10/12 to make it the 12th root of all of it. And I just left it as 3 to the power of 11 because 3 to the power of 11 is a pretty big number, so I just left it in radical form or in exponent form. But if you multiplied it out, that'd be fine too. And then for part B, we can multiply these two terms if we make the bases the same. So you can rewrite this as 3 to the power of -1 and 9 as 3 squared. So that gives you a product of two terms with exponents. So you just add up the exponents and you get 3 to the power of 7/10. All right, so we're going to start with a quick review of how to solve a radical equation. So the first thing you're going to want to do is to isolate the radical expression if you can. If there's more than one radical expression, you may need to take a different approach. Then you're going to raise both sides of your equation to the power that matches the index, and that will clear your radical. And then you just need to be careful because if the index is an even number, we need to check for extraneous solutions. And that's because our domain and range have restrictions because the radicand must be greater than or equal to 0. So this only applies when the index is even. So if you have an odd root, like a cube root equation, you don't need to worry about extraneous solutions. All right, let's give this first one a try together. So the first thing we're going to try to do is to isolate our radical expression, and we can do that by simply subtracting 2 from each side of our equation. And from here, we're going to raise both sides of our equation to the power of our index, which in this case is 2. It's a square root. Just be careful on the right side of our equation. We're going to do x minus 2, that entire binomial squared. And remember, we cannot distribute exponents to sums or differences. So on the left, our square and our square root cancel each other out. And on the right, we're left with x squared minus 4x plus 4. So you can see here we're left with a quadratic, so we can solve this by setting it equal to 0. And this one we can solve by factoring. So we get two solutions. We get positive 6 and negative 1. But since we do have an even index, we do need to check our answers for extraneous solutions. So let's check x equals 6. So we're just going to plug it in to see if we get a true statement. So here, the square root of 16 is 4, 2 plus 4 is 6, so 6 does equal 6. So that means that that is a solution. Now let's check negative 1. Okay, so here we get the square root of 9, which is 3. So this actually gives us 5 equals negative 1, which we can see is just not true, meaning that negative 1 is an extraneous solution, and meaning that we just have one answer, which is x equals 6. All right, let's try one more together. So here, initially, this might not look like a radical equation, but remember when we have a rational exponent, it can be rewritten as a radical. So this is just the square root of x plus 6 minus the square root of 2x minus 4 equals 0. So here, since we have two separate radical equations, we can't isolate them, but when you do just have two, we can, and there's no other terms in our equation, we can actually just set one equal to the other. So I'm going to add this to the other side, like this. And then we can square both sides, and that will clear our radicals. And then here we just have a simple linear equation. So we get x equals 10, but because it is a even index, we do need to check our answer. So let's substitute x equals 10. So we have the square root of 10 plus 6 minus the square root of 2 times 10 minus 4 equals 0. So this gives us 4 minus 4 equals 0, which gives us 0 equals 0. So we've confirmed that this is an answer, and it is our only solution. All right, let's look at another example together. So here we're going to take that first step to isolate our square root. And from here, if we stop and do a little bit of critical thinking, it could actually save us a lot of time. So here we have a square root, and we know that a square root will always yield a positive answer, unless there's a negative in front, which that would be the negative version of the square root. But this is just the positive square root, so this should always give us a positive answer or 0. Now, that means that the right side of the equation doesn't make sense because a square root can never yield a negative number. So from this point, if you catch this, at this point, you can actually stop and say no solution, because an even index radical can never equal a negative. However, let's say we didn't catch this. We could continue on. We could square both sides of our equation. So we get 4x plus 8 equals 64 because we're squaring the negative and the 8. And if we keep solving from here, we get 4x equals 56. So x is 14. And if you went to plug that in, you would see that that would be an extraneous solution. So here we get square root of 64, which is 8, and we know that 17 is not equal to 1. So since the only solution is extraneous, that would just lead us back to no solution. But remember, again, if you ever see any even root or even index radical equal to a negative number, you can stop there and just say no solution. All right, go ahead and pause the video and give this one a try on your own. All right, go ahead and check your answer here. Do make sure that you have checked to make sure that your solution is not extraneous, and our answer should be x equals 4. All right, now we're going to try one with a cube root, so that same general process. So again, we're going to isolate our radical. In this case, it's okay for a radical to equal a negative number because cube roots can produce positive or negatives. So any odd index is totally fine. So here we're going to raise both sides to the power of 3. We'll cube both sides. Remember, when we're cubing both sides, we are cubing the negative, so it stays negative. And then we subtract 2 and get x equals negative 10. So for these, we shouldn't get any extraneous solutions, but just to make sure, we could always plug in our answer to check. It's a good thing to do if you have extra time. So here we have the cube root of negative 8, which is negative 2, and then that gives us 5 equals 5. So again, with the odd index, we shouldn't be getting any extraneous solutions, but you can always plug in your answer to double check. All right, here's our last example that we're going to do together. So here our radical is already isolated, so we are going to cube both sides like this. Now when we cube both sides here, this clears, but remember on the right side of our equation, it becomes x plus 1 cubed, so we would actually need to multiply it out, or instead of multiplying it out, we could do a little binomial expansion, if you remember. So here's the third row of Pascal's triangle, and remember this degree term, it decreases and this one increases. So it should give us x cubed plus 3x squared plus 3x plus 1. And this one, it's even nicer to do that binomial expansion because the b value is just 1, so it makes it a little bit easier. So from here, let's set our equation equal to 0. And let's see if we can try factoring by grouping. So x squared times x plus 3 plus 2 times x plus 3. So this gives us x squared plus 2 times x plus 3. So this factor would give us two imaginary solutions. For radical equations, we won't be looking for any imaginary solutions, but our second factor gives us the real solution, x equals -3. And since it is an odd index, we shouldn't need to worry about extraneous solutions, but we could plug it in just to be sure since we have the time. So here, this gives us the cube root of -8, which is -2, and -2 is equal to -2. So I'd say it's definitely worth checking, even if it is an odd index, because maybe you made a small mistake and you can catch that. But again, if it is an odd index, you shouldn't expect any extraneous solutions. All right, here's the last one for you to try on your own. So please pause the video and hit play when you're ready to check. All right, go ahead and check your answers here. Remember, when your rational exponent is 1/3, it just means a cube root. And then make sure you divide by 2 on both sides to isolate your radical, and then you can cube both sides and finish solving for x equals -120. Again, you could quickly check your answer just to make sure it is correct. All right, that is all for today's video. Thank you so much for watching.